Okay, well, let's move on to Super Jackknifer. We're up to 66 reports and 3 graphics. Okay, what does Super Jackknifer do? Well, let's push it. A jackknife is another resampling technique, one that's often used to estimate the standard error of a parameter distribution. But unlike a bootstrap, where it will sample randomly a number of records from the original data set, the classic jackknifing approach to estimate the standard error and thus the significance of a parameter is the leave one out strategy. That is, let's say you have 237 cases or observations like we do in this data set. It will run the model, whatever it is, the PLS model in this case, using all of the observations except for the first one, and it will record all the results. Then it will run the model using all of the observations except for the second one and look at the parameter estimates and store them. Then it will run the PLS algorithm estimating all of the parameters on the original data set except for the third record, and it will record all those estimates, and so on for the fourth, fifth, and sixth. So if you have 237 records, or whatever the number is, that's the number of resamples that you will always get in a jackknife. Bootstrap, you can determine how many resamples you want, but a jackknife in the classic leave one out implementation is always, the number of resamples is always equal to your number of original records. Plus, the jackknife results, that is with respect to the calculation of the standard error in the observed distribution or density function for each parameter, every time it runs this, it gets a different value, slightly different value for a parameter, and you can plot them as a density function. That density function will be the same jackknife after jackknife. That is, every time you do another jackknife, you come back an hour later, run it again, you're going to get the same answer because it deletes one at a time. You have the same input data. There's no variability like you have with bootstrapping. Okay, so let's say we want the summary reports and the detail reports, and we're going to save them so we can put them in our folder there that's stuffed already, and we say run. It'll be exactly 237 resamples. So when I bootstrapped, I did 100 resamples. So this is taking a little longer. And it's just running PLS minus one of the observations, estimating all of the parameter values, storing those parameter values, then running it again, doing it, going through this iteration again 237 times. And then we can plot all of the, for the path coefficients, weights and loadings, R squared, direct effects, indirect effects, all 16 of those parameters that are estimated, the first eigenvalue, second eigenvalue, AVE, Dillon-Goldstein row, everything that comes out in an output report from a single PLS run as being a parameter that is estimated. We can look at the density function and we can see if it's significantly different from 0, if that makes sense for that parameter. It doesn't for all of them. So it's producing the reports, takes just a second to do it. And so let's go over here. You'll notice the tabs say what it is. So the jackknife starts here. The format and the information in the jackknife reports is the exact same as in the bootstrap, with a couple of minor changes. For the summary reports, you only have a normal CI. It doesn't make sense to have a percentile confidence interval, but you have significance levels. These are the path coefficients, and you can compare them. They're going to be close to the other ones, but not exactly the same. The only one that is not significant, again, is this one. So we have, for the summary reports, we have the same parameters, summary reports, path model coefficients, the loadings, the weights, the latent variable scores. Notice all of these confidence intervals straddle 0. They should, because these are standardized. It doesn't make sense to test if it's different from 0. We don't want to see a latent variable that's different from 0. Direct effects, same as the past, but you also get indirect, which can be useful if you're looking at mediation. Total effects, the average variance extracted, the R squared, everything, average communality, redundancy, Cronbach's alpha, Dillon-Goldstein's rho, first eigenvalue of the principal component, second, jackknife, everything. Then you get the detail reports, and those are going to have exactly 237 records. I'm sorry, this data set has 426 records, my mistake. So you're going to get exactly 426 records. It is just like the Bootstrap reports, but the algorithm is different. It's a classic leave one out resampling strategy, which is useful. It's useful to have more than one resampling strategy that you can report on and analyze, because studies with small number of observations or large number of observations, you can get different results with jackknife versus bootstrapping. And there's some cases where you want to do a jackknife and some where you want to do a bootstrap. Most of the tools, the PLS model, path modeling tools, well, not all of them. Some of them only have bootstrapping capability. But it's useful to have both bootstrapping and jackknifing capability. Also, I think it's useful to have those resampling tools for indirect effects, total effects, so you don't have to do it by hand. Note now, if we come up here to the top and we right-click, these are the number of reports that we've accumulated -3. So we have 98 reports and 3 graphics, and we can go over here into the reports directory, and you can see here's the bootstrapping and the jackknifing. This is sorted alphabetically, but we're getting quite a collection. Let's go over the graphics directory. There are only 3, and this will change. I will add quite a few plots, interesting 3D plots and motion plots, but not right now. Okay, so we have one more capability in the tool as it stands today to look at, and that is this R Commander button. What does this R Commander button do? We'll take a look at that next.